The predator has no idea it just swallowed a live chemical reactor. The frog's tongue strikes its target, but the millisecond it is pulled into the maw, the prey's defense mechanism engages. A sharp series of popping explosions echoes out, and in sheer panic, the frog spits out its meal. The hunted strolls away, its bioarmor without a single scratch. The creature that just hacked the frog's digestive system is Pheropsophus jessoensis, the Asian Bombardier Beetle. It weighs a mere 0.007 of an ounce, but do not let that number fool your radar. This is no ordinary insect. It is an armored tank equipped with a mobile chemical weapons system. The moment it is clamped down on, its neural reflexes fire a payload straight down the enemy's throat. This catastrophic thermal and gustatory shock might not be an absolute shield, but it is enough to drop most opportunistic predators, forcing an immediate abort of the swallow command. What kind of fluid mechanics technology engineered this firepower? MIT threw its North American cousin, Brachewinus elongatulus, into high-speed X-ray scanners at 2000 frames per second to dissect this blueprint. Beneath the shell lies a literal liquid fuel rocket engine system with 2 isolated payload bays. Nature's absolute genius lies in the architecture of the reaction chamber. The exoskeleton here is spatially heterogeneous, mostly ultra-hard armor to bear the load, but lined with flexible expansion joints along the seams. This design allows the chamber to dynamically deform, absorbing the pressure shockwave without shattering into shrapnel. Upon activation, raw propellant is pumped into the chamber, collides with catalytic enzymes, and detonates. It unleashes a massive energy spike of 0.004 of a joule per pulse. The chemicals instantly vaporize, launching out of the exhaust port at 22 miles per hour. Emphasizing one point, the mechanical kinetic energy of the jet is nearly 3/10,000,000ths of a joule. It is completely physically harmless and could not push back a thing. The true lethality lies in the thermochemical energy. A 212 Fahrenheit toxic mist packed with irritating p-benzoquinone literally boils soft tissues and crashes the sensory system, forcing the enemy to drop the target without leaving permanent physical damage. But a 212 blast inside its own body, how does it not rip its own armor to shreds? The sudden vaporization generates catastrophic internal pressure. Nature's workaround is switching from continuous exhaust to a pulse jet engine. The key is an expansion membrane. This membrane is impossibly thin, measuring just 0.08 of an inch. When chamber pressure hits the ceiling, it inflates by 280% to seal the intake valve in just 0.06 of a millisecond. The moment the payload vents out, pressure suddenly drops, the membrane deflates, and the intake valve automatically opens to load the fluid for the next launch sequence. This process is known as passive mediation. Once the initial blast is triggered by a tiny muscle cluster, this system requires absolutely no further neural signals or muscular control. This load, seal, detonate, and exhaust cycle sweeps through the system at an average frequency of 698 times per second. Let us do the math. Even when a V8 race car engine runs at the red line of 8,000 revolutions per minute, its intake valve only opens and closes about 67 times per second. This biological valve, a mere 0.08 of an inch thick, operates 10 times faster than humanity's peak mechanical engineering, continuously enduring boiling temperatures and extreme pressure without degrading. Precise. Efficient. Physics optimized to the absolute limit. Nature never stops proving that the most flawless mechanical blueprints sometimes fit perfectly inside an organism weighing a tiny fraction of an ounce, right under our boots. Hit subscribe to join me as we tear down Earth's greatest machines in the next episode of Technical Breakdown.